Hello, everyone, and welcome. Thank you for joining us today as we explore getting the big picture, hybrid network visualization for the cloud. My name is Claudio Palais, Senior Content Manager for NetBrain, here with my colleague George Logarakis, who will be graciously demoing the comprehensive and automatic discovery, mapping, and visualization of hybrid and multi-cloud networks with NetBrain. Now, it probably goes without saying that most organizations are embracing the cloud and all the benefits that come with it. And it's not necessarily for reasons one might think. According to a 2021 report from Gartner, only 17% of organizations migrating to the cloud list lowering costs as their top motivator. They further note that more than 50% of enterprise spending in key markets is estimated to be allocated to cloud infrastructure by 2025. That would be $917 billion in 2025 versus just $868 billion for traditional network infrastructure. 2021 saw a 41% growth in infrastructure as a service, while Flexera's 2022 State of the Cloud report sees a 29% jump in organizational spending on cloud over the next 12 months. Already this year, the average cloud spending is 13% over budget. So why are businesses transitioning to the cloud? In that same 2021 study, Gartner found that organizations are looking to obtain greater flexibility and agility with cloud and seeking to reduce the need to maintain and support on-prem hardware and software. And that has really pushed demand for overall greater visibility of cloud assets and visibility into how cloud infrastructure communicates with legacy on-prem networks. Enterprise Management Associates estimates nearly 87% of IT organizations believe a single visibility architecture spanning physical, virtual, and cloud networks is important. You won't get this when migrating to public cloud providers, but it is something you'll see later in this webinar that NetBrain provides out of the box. What are some of the other top challenges businesses are finding as they transition to cloud? Well, as Gartner noted, network operations teams are forced to operate differently depending on whether their networks are in the cloud versus on-prem. Here are 4 ways cloud introduces or exacerbates network challenges. Let's start with documentation. Somehow, considering the pain with traditional networks, proper documentation of cloud infrastructure is even more of a lost cause. The cloud is a black box. Most enterprises can't or don't know what they have in the cloud. One client, when asked how they, before NetBrain, accounted for the amount of infrastructure they had in the cloud, stated simply, "We wait for the bill." And with the way cloud dynamically scales, the use of resources grows, many times without even knowing. Another challenge is collaboration. Cloud, like networking, is a specialized discipline. Many organizations hire and build new cloud teams to deploy and support their cloud infrastructure, a lot of times outside the network operations umbrella. This necessitates building a collaborative and productive working relationship between IT support teams that require processes and tools. A big puzzle is application performance on hybrid network infrastructure. While services and app support might be different depending on whether an app is on the cloud versus on-prem, end users' expectations remain the same regardless. Ops professionals must use their disparate skill sets between traditional and cloud to ensure the exact same performance and delivery of critical services and apps. Finally, silos. Cloud flexibility brings agility, but the virtualization and multi-tenancy that make that possible segments visibility and contributes to information and data silos. In traditional networking, routing, switching, and firewall teams have their own data and skill sets, but there are also processes developed to aggregate that data and leverage it appropriately and efficiently. The question is, how do we now integrate all this new cloud data into our processes consistently? And here, addressing these challenges is where NetBrain's value becomes apparent. Whether traditional, virtual, SDN, or cloud, NetBrain provides the means to manage the entire network infrastructure end-to-end. NetBrain is the industry's leading visual network management and automation platform, focusing on problem diagnosis of hybrid, multi-vendor, and even multi-cloud architecture at scale. Okay, so how do we do it? For cloud, we address its challenges in 3 categories. First is observability. Observability addresses the problem of the black box, using APIs to obtain the context of the cloud architecture and demystifying its landscape. Second is troubleshooting. NetBrain's approach to troubleshooting addresses the collaboration hurdle with our incident portal and runbook automation, which in turn, along with NetBrain's application paths, expedites problem diagnosis and dramatically reduces MTTR to also address the application performance challenge. The last category is the single pane of glass. NetBrain leverages and consolidates data and information from various sources into one repository to build a digital twin of the entire network whose topology is visualized with dynamic maps. Gone are the days of information silos. The lack of up-to-date comprehensive documentation is a thing of the past. Let's delve deeper into these categories. With observability, NetBrain provides full integration with the leading public cloud offerings. In 2021, Amazon retained the #1 position in the cloud market, followed closely by Microsoft and Google. Together, they account for 70% of the market share. NetBrain integrates with all of them. That means enterprises can take advantage of cloud diversity and still rely on NetBrain to efficiently manage and map their multi-cloud network from one place. What does NetBrain provide? Well, 1. Auto-discovery of public cloud resources, visualization of cloud components such as VPN gateways, EC2 instances, cloud VPCs, cloud routers, and the like, and 3. Visualization of topology and techniques like express route connection, direct connect, partner interconnect, or site-to-site VPNs. Going further, NetBrain's dynamic maps are real-time and can visualize end-to-end traffic paths. These aren't static diagrams. NetBrain consults the routing and policy information of its digital twin to provide the actual paths traffic takes, regardless of whether the endpoints begin or end in the cloud or on-prem. NetBrain can visualize any path, even if it traverses multiple clouds. For troubleshooting, NetBrain's cloud management portfolio encompasses end-to-end application path visibility, runbook automation, and the incident portal for collaboration across multiple teams. We just discussed end-to-end application path visibility, and the best part about it is that because NetBrain utilizes and visualizes the forwarding information of every node in the path, support teams can quickly identify and remedy any path-affecting misconfigurations like ACLs or firewall policies, or even degraded or erroneous states in the forwarding tables. Runbooks, on the other hand, can memorialize and digitize your expert's best troubleshooting techniques without code that can then be triggered as automation via external events like incoming trouble tickets, greatly reducing incident response and mean time to resolution. NetBrain also provides the incident portal, where members from various support teams, routing, security, application, or cloud, can troubleshoot an incident together in real time. All actions are documented, so messy handoffs and escalations can be avoided. And because NetBrain captures the diagnostic and troubleshooting steps of your best engineers that can then be shared across the organization, you'll always have expert knowledge even when your subject matter experts aren't available. Finally, a little more on single pane of glass. This becomes so critical in the cloud environment, not just because of the various cloud vendors, but because, along with runbook automation, this addresses the issue of data silos. Even looking at the number of data solutions out there for cloud, there's no easy way to aggregate and consolidate that data to make it useful. NetBrain provides ecosystem integration with third-party cloud data monitoring and management tools, allowing for real-time visualization of these third-party data sets. At this point, you might be anxious to see it in action, so this is a good time for me to hand over to my colleague George, who will demo what visualizing cloud networks with NetBrain actually looks like.
Thanks, Claudio. So with this demo, I want to start by talking about how NetBrain discovers the public cloud. And for those of you that may not be aware, NetBrain discovers AWS, Azure, and the Google public clouds via API. And it's a really straightforward process, actually, to set up this discovery and discover your cloud. So to do this, you would simply add your API server. And for example, if I'm specifying AWS, you would add all the server information. So the server name, and this name that would be in NetBrain, and then the account information for that public cloud, and then save that. And NetBrain can immediately start using that to discover your public cloud. So that's the how NetBrain discovers the public cloud. Let's start talking about what NetBrain is going to actually be able to discover within your public cloud. So if I move over to the scheduled benchmark task, and that scheduled benchmark task is going to be this task that follows up on the discovery and pulls in the detailed data from the hybrid network, which includes the public cloud. And to get a feel for what kind of data and data tables NetBrain is pulling from the public cloud, let's take a look here at this list of data. So if I scroll down just a little bit, because we are in alphabetical order here, the first public cloud we're going to run into here is AWS. And you can see just this wide variety of different tables from AWS that NetBrain's pulling in from all those different AWS elements or devices. So going on a little bit more is going to show you what we're able to pull from Azure. And again, another fairly wide variety of tables. So we're going to pull in a lot of great information. And if I go down just a little bit more, I'm going to see that Google Cloud information. Again, a good variety of information being pulled from those different cloud-based elements. So that's what data NetBrain is pulling in. But a really important clarification I want to make here is what devices are we going to be able to visualize and pull this data from, right? So if I flip over here to my multi-vendor support, I've done a search here for Amazon to pull up the AWS device types that NetBrain is going to, one, discover, and number two, be able to interrogate and get all of this different information from. So, things like the EC2 instance, the virtual private gateways, the transit gateways, VPC routers, etc. And the highlight here, the AWS firewall, which we also do support with NetBrain. We're able to get information from all of those different elements. And if I did a quick search here, for example, for Google, I would see this the same thing here in the different end system or the VM, the different types of VPC router, gateways, load balancers, firewall, etc. The one thing that's not shown here is there are, or rather I should say, there are some elements in the cloud that NetBrain will display on a map, but that we're not actually pulling information from. So you won't see them on this particular list. And it's things like, for example, an AWS public service. Those will display on a NetBrain map, but we're not able to pull the information from them. So now that we know and have seen how NetBrain discovers the public cloud, which is through API, what data we're pulling in from the public cloud, which, as you saw from the benchmark task, is a very wide variety. And now we've seen what kind of elements from the public cloud NetBrain is going to discover and visualize for you. Let's talk about how NetBrain is going to visualize that and how quickly we can actually start standing up maps of the public cloud. So now I'm in a fresh desktop of NetBrain, and there is multiple ways to actually map out the public cloud and kickstart sort of mapping out your public cloud environment. The easiest way, and the way I'm going to show today, is the network context pane. And the network context pane is going to be able to show you the entire structure of the public cloud. For this AWS example I have here, we're going to go from account to region. And within each region, we're going to see the different VPCs. And even within a VPC, we'd see the different elements within that VPC, as well as the subnets. And within each subnet, we're going to see the EC2 instances. Now, how does this help me map? Well, if I select one of the VPCs, for example, NetBrain is going to automatically generate what's called a context map. So these are maps NetBrain's automatically creating and that are really great to help kickstart the process of demystifying that public cloud by creating these maps. So all we have to do is click Open Map, and NetBrain is going to give us the map of the public cloud. And it's a complete dynamic map of the public cloud. So we have all these different elements here. I can double click a load balancer, see the device properties, see the different data tables that NetBrain is able to pull in from that wide variety I showed in the benchmark task, and see what data we have here. So we have something in the load balancer listener table here, for example, and we have a lot of different device properties that NetBrain's pulled in right from the cloud. What else can we do on this map? Well, we can extend more neighbors. If we wanted a full picture, we can, perform a lot of different checks. One of which, I have an example here of a data view template called AWS Infrastructure View. Now, this data view template is going to pull in information from the public cloud AWS again for this example and overlay it on our map. And you'll see here when I pull up the result, it's going to give us different critical information for each element of the public cloud. So again, if I look at this load balancer here, we're seeing the DNS name, the hosted zone, and we can even look and see availability zones. And this is being pulled and can be pulled live from the public cloud. And the great thing about these data views, you can also have them set to run at a frequency. So we can also have it sort of be a short-term monitoring of the cloud if you want to monitor if any of these values change. So what else are we pulling here? Well, you can see for each different element, here's a gateway here, we have some different information. Even we have some pop-outs here for certain elements with policy information. So we're pulling you that configuration right out of from the cloud as well, using that API information. So, this is great. Now, how's this going to help me troubleshoot the cloud? And that's sort of a use case I want to show next, because not only can NetBrain give you this information so you can, understand your public cloud and demystify it, we can use it to troubleshoot and help reduce the finger pointing between, the NetOps team and the cloud teams that could be happening when no one can concretely say where the issue lies. So I have this example here of an incident where that came in where the legal team cannot access the contract database. Pretty critical incident because the legal teams deal a lot with contracts. So what's the first thing we've done here? And there's two things happening in this incident here. The first thing we've done here is executed some intent-based automations on the traditional side of this path, as it does start in the traditional and go to the public cloud. So these intent checks on the traditional side are checking things like connectivity, performance, and topology. And as well as we have a check here, because we know there's a VPN connection between the cloud and the traditional network happening here, we're also verifying that VPN. We could dive into these checks. So for this particular check, actually, we have a diagnosis tree. So NetBrain has this feature of diagnosis tree where the result of one network intent can trigger another. So then you can have one intent end up triggering 4 in a row, depending on logic. So in this case, we had a check of the routing tables to validate that the next hop addresses haven't changed, to validate that our path has not changed. And since it has validated, we also want to check now, is there connectivity? And we also want to check the performance. Everything here is coming back green, meaning these checks have not found a problem, which means that, at the time of incident when this came in, NetBrain was able to completely determine that the network is not to blame. So with 3 automated checks, we've absolved the network. We've realized the network is not at fault for this issue and can provide this as evidence to the cloud team that this is the case. So there's no more finger pointing because now we have some evidence to back up and narrow down exactly where the issue is happening. Speaking of where the issue is happening, now that we know it's in the cloud, NetBrain is still actually going to be able to help us get more details for the cloud. So imagine that. Not only can we say, hey, the network's not the problem, NetOps is off the hook, we can now look in the cloud and perform some operations to either provide the cloud ops team more information for their troubleshooting, or maybe the cloud ops team can then come in and perform these steps. So what steps can they perform? Well, we have a recommended runbook here with a few checks within, and I'll show you what that looks like. So there's a few things happening here. 2 data views and a path. The first data view is actually pulling in some metrics from an external monitoring tool that we're using to perform some real-time monitoring on our cloud environment. So NetBrain has really robust and easy API integration with these tools to be able to let us pull in their data and become that single pane of glass. So let's see what that result shows us. So our monitoring tool is showing us with some metrics here, CPU, space, RAM, etc. We're seeing all these different metrics pull in from our monitoring, but nothing is really showing us anything that is pointing to a root cause. So, that's awesome, right? That's great to see that nothing here is suspect so far. So let's move on to that other check. And this is the one I showed you earlier, where we're going to get that infrastructure information from these different elements of the cloud. So again, I can come here, I can see some information about this VPC. And then I can also see some information here from the EC2 instance. So this is good information that maybe the cloud team could look through and see if they find anything that doesn't make sense, that could be pointing to a root cause. In our case, we may still just be the network guy. So right now, there's nothing jumping out to us saying this is the root cause. So what's the last thing we can do is draw a path in the cloud. So this map was part of the automations here that were triggered at the time of incident. NetBrain also gave us this map. So the other thing we want to do is revalidate this path, because the path that it's showing is probably the expected path for the traffic. So we can do that here again within the runbook, or up here in the path menu. And I can map out that path. And we see another line up here. And let's view the details of that path. So what I want to point out, first of all, is talk about how NetBrain is making this path. Now, some of you may know this, but NetBrain's paths are more than just a trace route. So we're actually going into these devices, and I'll show you here. We're actually going into these devices, and we're performing almost 20 different checks to determine what is the next device in the path. And when it comes to the cloud, if we go to here, we can see that we're actually looking into cloud elements for this information. So we're actually looking at the virtual routing table here in this virtual gateway, and that's being pulled in from the cloud. And we are matching entry in that table to determine what the next hop is, which is this device. Now, if we look at the full result of our path as this keeps going, we can see that, oh, there was an issue here. And the issue is that we actually are checking the EC2 instance and checking those input security groups. And this is failing to match security group rules. So it looks like traffic is being blocked due to a security group issue on the EC2 instance. So in this case, now we know what our issue is. So now we can even pass this off to the cloud team, or if I am the cloud team, now I know exactly where to look and where to resolve. So I'm still getting to that resolution much quicker than if I had to validate this manually. And that's really where NetBrain's helping with the cloud. And just to build on to this pathing, now that we've seen how it can help with this example, NetBrain also helps and can path in a multi-cloud environment. So I'm going to go another example here where we can actually path from a VM in our Google Cloud all the way to another VM that's in Azure, or we could even do it from Google to AWS. And the principle here still remains the same, where we go to each device and pull the relevant information, do the different checks to determine what is the next device in the path. So, if we go to that Azure, again, we're checking the Azure virtual route table to get information, finding that next hop, etc. And each cloud device is going to have its own unique information, right? And that NetBrain is going to check based on that device type, just as it would with a traditional network. So the last thing I want to touch on when we're talking about the cloud is documentation. So NetBrain's documentation completely supports the public cloud. The first documentation element I want to talk about is the inventory report. So the inventory report, specifically these built-in reports here that we provide you, are gonna, contain your public cloud elements as well. And you could even make custom reports showing only the cloud elements. But they do appear in inventory reports, and we can pull information for these inventory reports. The other type of report that we support from NetBrain is the change analysis report. So I just ran this report looking for changes on my network over the last 7 days. So we can see which devices have had changes in the last week. We can even pick certain data types if we wished. And I want to look for my cloud. So I'm going to search for a keyword for my cloud, which is VPC. I can see that this device here from my AWS cloud has had a change on the AWS ENI interface table. With one click of the compare button, I'm going to see that, okay, between these 2 days, the 23rd of October and the 22nd, this interface was removed, but then another interface ID was added. And I can actually see what those values were. And I actually can get that complete visibility into what's been added or removed. And if it was modification, we'd see that as well. So we're eliminating that stare and compare by showing you on this table what exactly has changed. So that's all for the demo I had for the public cloud. I'm going to turn it back over to Claudio to wrap up the webinar, and the team will be happy to answer any of your questions during the Q&A session.
Thanks, George. Great demo. Highly appreciated. Before we get into the Q&A session, we'd like to thank everyone for taking the time to join us today, and we appreciate your presence. We'd also like to provide you with a scannable QR code and a link where you can schedule your own demo or get started with a test drive. We also have a ton of information on our latest and greatest release, R11. You can also find info on future webinars you might want to sign up for, so please follow the links when you get a chance. So now we're set for our Q&A. Looking forward to answering any lingering questions you might have concerning cloud visibility with NetBrain. So we have a couple of questions already, great questions, but for those of you who are not aware, you can enter any questions you might have in the chat. But let's get started with some of the ones we already have. So George, one good question is, can NetBrain discover services from many sub-accounts in AWS without having to manually add all the sub-accounts separately?
So yeah, this is a great question. So we can discover services from multiple accounts. However, our recommendation is that you do add all of the accounts you wish NetBrain to discover. You add them into NetBrain so we can ensure all information is discovered. We may be able to tell you if a certain VPC is linked to multiple accounts or anything like that, but to get the best and most robust use out of the tool, we recommend adding those accounts.
Great. And then also regarding some of the actions you were doing on the demo, when you get the failed to match security group rules, where did you define those rules?
Yeah, so where do we define those rules that were expected? So what this path is actually doing, and when it comes to those security group rules, is NetBrain is actually using that API information to check the already existing security rules, or so I should say existing security groups that are configured on that EC2. So what NetBrain is doing is analyzing the EC2 group or EC2 security rules to see if any of those rules would match and fit the path and allow that traffic to get through. And because it's not finding a security group rule that's allowing traffic from that source, then NetBrain is saying that this traffic is blocked because it does not match the group rules.
Gotcha. And then another question is, can NetBrain discover the underlying network in Azure?
Yeah, so I showed it in the beginning, but NetBrain does discover Azure, and it will discover all the Azure virtual gateways, firewalls, and all of the networking elements within the Azure cloud. If there's a little more clarity to that question, you can ask again, but we do discover the networking components in Azure.
Here's a really good one. So this one user uses Palo Alto firewalls in Azure and Google Cloud. Can NetBrain map those as well as be aware of the firewall rules?
So the answer here is yes. So if you have virtual devices within the cloud, whether it's Palo Alto firewalls or ASAs, we are able to map those and be able to access them as if they were normal firewalls. So if you did have credentials and you could log into those firewalls like they were physical devices, NetBrain can make use of that as well to get even more information from those firewalls.
So similar to like if they were in a traditional network, if they were hardware appliances or even virtual, but in on-prem.
Exactly. And but when we map them, we'll even show you that they're in the cloud and where they're connected.
Cool. And lastly, does NetBrain support Microsoft Windows 365 tenant hosts connected to Azure?
So when it comes to the application more centric side in the cloud, we have some visibility, but it might not be you know, complete visibility that you might be looking for. In this specific case, I'm not aware of the specific answer here, but I know we do show some of the services, and but mainly our focus in the cloud is the networking side, so those virtual gateways, those routers, and how you would get to the VM or the service. I don't, so that visibility may be a little bit out of our scope.
Okay, well, I mean, thanks again, George. Thank you for those great answers, and thank you to all the participants. Those were really great questions. We'll wrap it up here. I hope all of you enjoyed, and we'll see you at the next webinar.